In the space of science and massive secrets, the subject of what existed before the tremendous blast has sparked mixed discussions and charmed thinkers for a very long time. This gigantic inquiry not only tests how we comprehend the universe but challenges the actual limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast unknown, and pondering what lay there before our universe came into being. The event of the Big Bang marked the dawn of humanity, space, and all that we know. Yet, was there a moment before this? Could there have been a state of nothingness, a quiet before the cosmic gathering began? And if this is true, was it truly nothing, or perhaps something far more complex that existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, into ideas that challenge our understanding. Physicist Brian Cox, known for his exploration of the wonders of the universe, suggests that something astonishing could have existed before the Big Bang. He invites us to reconsider our understanding of reality and existence. In this examination, we will dissect the science, the theories, and the incredible mysteries that could explain what existed before it all. We'll explore concepts like inflationary development, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astound you, but they might also open new perspectives on our place in the universe. To appreciate what might have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. Scientists define the Big Bang as the moment when the universe became incredibly hot and dense, expanding rapidly to form all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this fiery beginning, with galaxies spreading outward from an initial point. But why did this happen? Moreover, was there a time before this hot, dense beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Inflationary theory suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, essentially like a massive vacuum. However, this vacuum wasn't completely empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it laid the groundwork for everything to follow in a fraction of a second. Space expanded at incredible rates until inflation slowed down, and the energy transformed into matter, particles, and the forces we associate with the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe, and why did it stop? Scientists believe that this cosmic expansion created pockets of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and a limitless number of universes. Our universe is just one of many. This vast, mind-bending reality challenges our understanding of existence itself and leaves us with the question, what else is out there? The notion of nothingness before the Big Bang is speculative, not conclusive, based on our current understanding. Even if you remove all energy, particles, and radiation from the universe, it still wouldn't be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create a complex cosmic tapestry. Even in its emptiest state, the universe generates new forms of energy. This fact alone is puzzling to scientists, as it suggests that true nothingness might be impossible within our infinite reality. Space itself has properties, rules, and constants that prevent it from being entirely void. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and disappear, creating a ghostly resonance of activity even in what should be empty space. This challenges our very idea of a true void and suggests that, yes, even before the Big Bang there was something. Scientists are only beginning to understand this. One of the most fascinating theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's possible that it could continue forever. Brian Cox describes an unimaginably vast inflationary multiverse where universes are infinitely created and continue to expand. Imagine each Big Bang as a spark igniting another universe, while inflation continues in different regions, generating countless other universes. This could, in theory, go on forever. If this theory holds, our universe is just a tiny fragment of an ever-expanding cosmic web where new universes are constantly being born. This raises even deeper questions. Are these universes connected? Do they interact in ways we can't yet see? Could remnants of past universes influence our own? Some physicists, including Sir Roger Penrose, suggest that evidence of a pre-Big Bang universe might still exist within our own. Penrose's theory, known as conformal cyclic cosmology, CCC, proposes that our universe is just one in a series of cosmic cycles. In this model, each universe expands, ages, and eventually fades into near nothingness, only for a new universe to arise from the remnants of the previous one. According to Penrose, hints of these past universes could still be imprinted in the cosmic microwave background radiation, the faint glow of the Big Bang. This idea is both captivating and unsettling, as it suggests that the universe we know, and everything in it, might be part of a cycle that has played out infinitely many times before and will continue long after we're gone. The role of quantum mechanics in pre-Big Bang theories offers yet another approach to understanding what existed before. At the smallest scales, reality behaves in ways that defy classical intuition. In the quantum realm, particles can appear and disappear randomly, and time itself becomes less rigid. Some physicists believe that before the Big Bang, the universe existed in a quantum state where space and time were not yet defined. Instead of a specific moment of creation, the Big Bang might have been a quantum transition, an abrupt change in energy that triggered the birth of space and time. One compelling idea is the quantum bounce hypothesis, proposed by researchers working in the field of loop quantum gravity. According to this hypothesis, rather than a single beginning, the universe might have undergone cycles of expansion and contraction, never truly reaching a point of nothingness. Instead of a Big Bang, there may have been a big bounce, where a previous universe collapsed under its own gravity and then rebounded into the one we inhabit today. This would mean that time didn't begin with our universe but extends infinitely backward, with universes being born and reborn in an eternal sequence. The implications of a pre-Big Bang universe. If something existed before the Big Bang, it changes everything we think we know about cosmology. It suggests that our universe is not unique, that the fabric of reality extends beyond what we can see or measure. But the limits of human understanding. One of the biggest challenges in exploring the pre-Big Bang era is our limited ability to observe and measure it. Since we can only study the universe as it exists after the Big Bang, everything before it remains speculative. However, theories like cosmic inflation, quantum gravity, and multiverse models offer glimpses into potential answers. As technology advances and our understanding of physics evolves, we may one day uncover more tangible evidence of what came before the Big Bang. Until then, the question remains open, a tantalizing mystery that continues to challenge and inspire scientists and thinkers worldwide. Perhaps, in the end, the search for what existed before the Big Bang is not just about understanding the past, but about redefining the future of human knowledge itself. Reconsidering the nature of nothingness. Unaffected by the others, the rapid expansion of space under the inflationary theory suggests something both exhilarating and unsettling, an infinite multiverse with no definitive beginning or end. Imagine our universe being merely a tiny speck in a giant, vast expanse, continuously expanding and endlessly creating new universes. And what if the unsettling truth is that there is no before or after, but rather an eternal pattern of universes forming and dissolving? Our interpretation of nothingness shifts when we consider quantum field theories. According to these ideas, the universe is not just an empty collection of matter floating in space. Instead, it's a complex network of energy fields and quantum phenomena. Even in the most empty of voids, quantum fluctuations cause particles and energy to spontaneously appear and disappear, ensuring that true nothingness may not exist at all. The eternal dance of universes. The quantum bounce hypothesis and the idea of a multiverse suggest that what we perceive as the birth of our universe is merely one act in an eternal dance of creation and destruction. If universes are born and reborn, it raises profound philosophical questions about the meaning of existence. Are we part of an infinite cycle with no true beginning or end? If so, does time itself have any meaning outside of the context of our specific universe? Eternal inflation implies that universes might not just emerge randomly but could follow specific patterns governed by quantum physics. For instance, regions of the multiverse could give rise to universes with varying physical constants. In one universe, gravity might be weaker. In another, life as we know it might be impossible due to a lack of chemical complexity. This paints a picture of an infinite variety of realities, each following its own unique set of laws. However, this also means that our universe, with its precise conditions for supporting life, might be an extraordinary coincidence, or the result of a natural selection process in which countless universes arise and only some are stable enough to persist. The search for evidence. While much of this theorizing is speculative, scientists are actively searching for evidence that could provide clues about what existed before the Big Bang. One such clue lies in the cosmic microwave background, CMB, radiation, the faint afterglow of the Big Bang. Physicists like Roger Penrose have suggested that subtle patterns in the CMB might be scars left behind by events that occurred before our universe began. For example, Penrose's conformal cyclic cosmology, CCC, theory predicts that certain anomalies in the CMB, such as concentric rings of temperature variation, could be remnants of black holes or other massive structures from a previous universe. While these ideas remain controversial, advancements in observational technology may one day confirm or refute them. Similarly, gravitational waves, ripples in the fabric of spacetime, could also hold hints about the universe's pre-Big Bang state. If detected, these waves might provide a glimpse into the dynamics of cosmic inflation or even earlier processes. The role of advanced physics. As we delve into these mysteries, advanced fields of physics like string theory and loop quantum gravity play a crucial role. String theory suggests that the universe is made up of tiny, vibrating strings that exist in multiple dimensions beyond the three spatial dimensions we experience. These extra dimensions could offer insights into pre-Big Bang conditions and the fundamental structure of reality. Loop quantum gravity, on the other hand, proposes that spacetime itself is made up of discrete chunks rather than being a smooth continuum. This could help explain how the universe transitioned from a quantum state to the expansive cosmos we observe today. Both theories challenge our conventional understanding of time and space, suggesting that the Big Bang might not have been the beginning in the traditional sense, but rather a transformation or a phase shift in an eternal process. Philosophical implications. Beyond the scientific questions, the idea of what existed before the Big Bang has profound philosophical implications. If the universe is part of an infinite cycle or one of countless multiverses, it forces us to reconsider our place in the cosmos. Are we insignificant in the grand scheme of an eternal multiverse? Or does the very fact that we exist mean that we are an integral part of this vast, interconnected reality? The concept of an infinite multiverse also challenges our notions of causality and purpose. If there is no definitive beginning or end, does the universe have any ultimate purpose? Or is existence itself the purpose? These questions, while deeply abstract, have a tangible impact on how we view ourselves and our relationship with the cosmos. The search for answers is not just about understanding the universe, but also about understanding ourselves. The future of exploration. As technology continues to evolve, we may one day uncover the secrets of what existed before the Big Bang. Advanced telescopes, quantum experiments, and theoretical breakthroughs could provide new insights into the origins of the universe. However, it's also possible that some aspects of this mystery will remain forever beyond our reach, limited by the boundaries of human perception and understanding. Even so, the pursuit of these answers is a testament to the boundless curiosity of the human mind. Whether or not we ever fully comprehend what came before the Big Bang, the journey itself expands the horizons of science, philosophy, and imagination. Perhaps the greatest lesson is that the universe is far more vast and mysterious than we can currently comprehend. And in exploring these mysteries, we are not just seeking answers about the cosmos, we are exploring the very essence of existence itself.